Hi class, so for this sections we're going to talk about trig functions. So for trig functions, pretty much you just have to memorize all the formula, just like how we have to memorize the power rules, product rule, and quotient rule. So trig functions, we have 6 more rules to memorize. Okay, so let's just take a look at some function. Now you can see right here, I introduced some proof for you. If you have time, go ahead read it. If not, you still have to memorize all of these trig functions. Okay, so you can see that's the derivative of sine of x is just cosine of x. Okay, so keep that in mind. Now, let's just go ahead and do number 1 right here. Number 1, hopefully you recognize that this is the product rule. So I'm going to label this f and g right here. So to take the y prime, I have f prime times g plus g prime times f. Okay. All right, so what do we have here? So we have f prime, that's 2x. G is just sine of x. And then f is x squared. Derivative of sine of x is just cosine of x. You can see that we cannot really simplify, so please keep it that way. Now, the derivative of cosine is going to be negative sine of x. Okay, so like I said, you just have to memorize these functions. Okay, they are closely related, so I think it's quite easy to memorize. Okay, so a sample 2. A sample 2, you can see that we have quotient rule, so I have to apply quotient rule. I'm just going to label this is f and this is g. All right, so for the derivative, hopefully you still remember, we have f prime times g minus f times g prime over g squared. Okay, so f prime secant of x, the derivative is secant tangent. It's right there, okay? Multiplied by g. I do not have any trick to memorize these functions. You just have to do it. So secant of x, and then the derivative of 1 plus tangent. Tangent derivative is secant squared. Everything over 1 plus tangent of x square. All right, let's simplify it. So you can see that, hopefully you can see right away that we have secant as a common factor. So if I take it out, I'm going to get tangent, right? If you FOIL, you will see it. And then we take the secant out. Tangent plus tangent square, and then we have minus secant square. Everything over 1 plus tangent of x square. Hopefully you remember this one, or at least you recognize it somewhere. So recall tangent square of x plus 1 is going to give you secant square of x. So you can see that if you rearrange it, tangent square of x minus secant square of x is going to be -1. So we can simplify it. So what I have right here is tangent of x minus 1 over 1 plus tangent of x. Okay, so that's going to be the derivative because I'm using, of course, I'm using the identity. Okay, hopefully that you see secant of x is never 0, right? Secant of x is never 0. So we can see that f prime of x is 0 when tangent of x minus 1 equal to 0, because secant can never be 0. Okay, so from there, you can solve it. Tangent of x equals 1. Okay, so what happened when you solve for x? X is going to be n pi plus pi over 4. So that's when we have tangent of x equals to 1. Okay? All right, moving on to example 3. Okay. Now you can see that once again we go back to velocity and acceleration. So hopefully you still remember the velocity function is the s prime function, and acceleration is the derivative of the velocity. Okay, so just keep that in mind. All right, now we're gonna have to do some work. So I'm gonna take the velocity first. The velocity is 4 negative sine of t, which is negative 4 sine of t. Acceleration, so I need to take the derivative of negative 4 sine of t. So the derivative of negative 4 sine of t is going to be negative 4, that's just a constant, cosine of t. So that's the acceleration. All right, let's take a look at example 4. Okay, so we have to find the 27th derivative of cosine. So let's just do it one by one and see the pattern. So f prime is negative sine of x. F double prime is negative cosine of x. Third derivative, we go back to sine. Fourth derivative, we are back to cosine. Okay, so you see that we get back to the original. So if you keep the same manner, we're going to get back to negative sine of x and so on. So you see that if we take it and we go to the power of 4, so let's say f of the multiple of 4, multiple of 4, which is 24. I have to pick a number, multiple of 4, but less than 27. So the multiple of 4 is going to give me back to the cosine. So f 25th is going to be sine, negative sine. 26, negative cosine. Therefore, f of 27, we get back to sine. Okay, so that's how you take the derivative. It's repeated. Okay, so it's just a pattern. Now, this one right here is quite interesting. Okay. All right. So what do we know? We have to find the limit as x approaches 0 of sine of 7x over 4x. Now first, I need to rewrite the function. The reason I want to rewrite the function is recall. Limit x approaches 0 sine theta over theta is going to give you 1. Okay, so keep that in mind. Now, I really need to rewrite the function so I can get sine of 7x over 7x instead of 4x. So how do I do that? Sine of 7x over 4x. Okay, so the goal right here is to get sine of 7x over 7x. Okay, you can see that we have 7x. We want 7x on the bottom. So I need to cancel out the 7, right? So I can put the 7 on top here. But I still have the 4 on the bottom. So on the bottom, I still have the 4. You see, the whole point right here is so I can cancel that and cancel that. Anyway, we don't want to cancel. We want to keep it that way because we're going to take the limit. All right, so let's take care of the limit. Sine of 7x over 7x. As x approaches to 0, is going to give me 1. You multiply by that 7/4, it's going to be 7/4. And that's our answer. Let's take a look at example 6 right here. So we want to take the limit as x approaches to 0, x times cotangent of x. You don't want to keep cotangent. So first, let's just rewrite. So I have the limit x approaches to 0, x cotangent is cosine of x over sine of x. Now, I'm going to take everything, I'm going to take the top, divide by x, and I'm going to take the denominator, divide by x. So what happened when I do that? So pretty much take everything, divide by x. Okay, so I ended up with limit x approaches to 0, and we have cosine of x over sine of x over x. Now, I can definitely break the limit, and do limit of the numerator, which is limit of cosine of x, over the limit of the denominator, which is sine of x over x. But we know that the bottom right here is going to yield to 1. Okay, so what I have is cosine of 0. I'm just going to use substitution over 1, which is 1. So there we have it.